Hello viewers, you're welcome once again. We are still under logic, Christ Almighty God's Algebra. Today we are going to treat Law of Commutativity. Law of Commutativity. We have two types of Law of Commutativity. One is Law of Commutativity by conjunctive statement, and Law of Commutativity by disjunctive statement. But we're going to start with Law of Commutativity by conjunctive statement. Let us start. Law of commutativity. P and Q is equal to Q and P. This is a typical example of law of commutativity by conjunctive statement. Law of commutativity by conjunctive statement. Because of this and connective that connect this P and Q, that's why it is law of commutativity by conjunctive statement. If you look at this equation, you will find out that this P, that is the first conjunct, this P is a first conjunct at the left hand side of the equation, while Q is the second conjunct at the left hand side of the equation. But in the right hand side of the equation, Q is now first conjunct, while P is second conjunct. That means they are interchanged. So whenever conjuncts are interchanged, it's still equivalent. It's still equivalent. It's still logical equivalent, like this. So we just commute the conjuncts, is still preserve logical equivalent. We are going to prove that law of commutativity exists by conjunctive statement. Proof. Suppose P and Q is equal to Q and P. We assume that the statement is true. We assume that the statement is true, that P and Q is equal to Q and P. So if this statement is true and it's a hypothesis, since it is true that whenever the left hand side of the equation is true, also the right hand side of the equation is also true. In the same vein, whenever the right hand side of the equation is false, also the left hand side of the equation is also false. You say that it is true. The statement is true. They are logical equivalent. So we assume that it is true, that is P and Q is equal to Q and P. If it is true, also this also must also be true. If and only if P and Q, if and only if Q and P is tautology. So P and Q, if and only if Q and P is tautology. You have seen that this statement has now been transformed to biconditional statement and is still preserved truth. It's still tautology. Because whenever the left equivalent is true, also the right equivalent is also true. In the same vein, whenever the right equivalent is false, also left equivalent is also false. So whenever we break this statement, there's no possibility of getting positive, always truth. We say that it is tautology, being justified by logical equivalence. Being justified by logical equivalence. Also, if this is true, also this also must also be true. So if and only if P and Q implies Q and the P is tautology. The bidirectional statement that is tautology has now also been transformed to conditional statement and it still preserves tautology. That means P and Q implies Q and P. P and Q implies Q and P is also tautology. That means the antecedent is a proper a proper implication of the consequent Q and the P. And if that is the case, when you read the statement, there's no possibility of getting positive, always truth. It says that statement is tautology, being justified by logical implication. Being justified by logical implication. So if this is true, also this also must also be true. If and only if P and Q is logical implication of Q and P. He said that since this P and the Q implies Q and P tautology, by the principle of logical implication, we then infer that P and the Q is logical implication of Q and P. That means the implication, that means the antecedent is logical implication of Q and P. By principle of logical implication, we then say that P and Q, since is a proper implication of the consequent Q and P, we then conclude or infer that P and Q is logical implication of Q and P and because the consequence. So it is true that P and Q exist because it's logical implication of Q and P. So if this is true, also this also must also be true. If and only if P and Q is equal to P and Q, that means the logical implication is equal to itself. Logical implication is equal to itself, and it is true that it is equal to itself because whenever the left hand side of the logical implication is true, also the right hand side of logical implication is also true. In the same vein, whenever the right hand side of logical implication is false, also the left hand side of logical implication is also false. We say that it is logical equivalent. So it is true. Being justified by identity, that means the sameness. Being justified by identity, that means the sameness. by identity. If and only if P and Q is equal to P and Q, and bracket not P or P. So we add this bracket not P or Q to P and the Q. This P and the Q is added with and bracket not P or P is still equivalent, because this not P or P is equivalent to T, and T and with any term same thing as that term by law of identity. So it's still equivalent to P and the Q. So being justified by law of identity. By law of identity. We continue. Say if and only if P and the Q is equal to P Q upon not P and bracket not P or P. You have seen that this P and Q has now been transformed to conditional statement. It is now not P implies Q and is intensified. It's now intensified. It's no more P and Q. It's now not P implies Q. That means it's now greater than P and the Q. And the not P implies Q. Not P implies, that means this means P or Q. That means not P implies Q and bracket not P or Q is certain as P upon, not P implies, that means Q upon not P. So you see that the right side equation now has not been identified. It has not increased in value. So it's now a superset of the left side of the equation. That means it's now intensification of the left side of the equation. We said that is intensification of P and the Q. So being justified by Christ Almighty God's grace. So through Christ Almighty God's grace that we transform this conditional statement P and the Q to conditional statement Q upon not P. That means not P implies Q. Being justified by Christ the Almighty God's grace. So if and only if our ink is having problem. If and only if P and Q is equal to Q and bracket not P upon not P or P upon not P. You see that you have now distributed this implication to the second conjunct. That means not P or P. As I distributed, this not P has now distributed to the second conjunct. That's why I have not P upon not P or P upon not P. Be distributed by this not P to not P or Q. So you see that it's now equal to, see that this not P upon not P is homology. Homology or with any term is the same as homology. Homology and with Q is Q. So, and you see intensification of the left hand side of the equation because Q is greater than the P and the Q. So you say its intensification is of P and the Q being justified by distribution of implication. Is through implication that we take this not P to not P or Q. That's why I have not P upon not P or P upon not P. So be justified by distribution of implication. We go to this side. If and only if P and Q is equal to Q and I'm going to revise this conditional statement that means not P upon not P or P upon not P. I'm going to revise it to conjunctive statement because it's being generated from conjunctive statement, that means from P and Q, which is conjunctive statement. So whenever I want to revise it, we're going to revise it to conjunctive statement because it's being generated from conjunctive statement. That means this implication is being generated from the conjunctive statement. So whenever I want to revise it, it's going to be a conjunctive statement. That means we're going to have bracket not P and P or bracket P and the P. And you see that this not P and P is F. F or with any term set on that is equal to P and P. P and P is equal to P. And Q, that means equal to P. Then I have now Q and the P. So it's not equivalent to this P and Q. Being justified, so it's no more intersection now. It's not equivalent to the left side of the equation. So being justified is through Christ Almighty God's grace that we transform this social statement to question statements. So we say being justified by Christ the Almighty God's grace. if and only if P and Q is equal to Q and T. Sorry, let's forget it. So T or bracket P and P being justified. So this not P and P is equal to T being justified by law of complement. By law of complement. Because through law of complement that you substitute this not P and P with T because they are logical equivalent. So, and it's still they are still equivalent to the left hand side of the equation, so it's logical equivalent to the left hand side of the equation. So if and only if P and Q is equal to Q and bracket P and P. So whenever this is T or P and P is equal to T is equal to T. Sorry, it is F. Sorry, it is F. Sorry, it is F, not T, because this not P and P is equivalent to F, and F all with any term is sent him at that term. I sent him as P and the P. So it's equivalent to the left hand side of the equation. Because this F or P and P is P and P, and P and P is P. That means equivalent to Q and the P. So we have P and the P. P and the P. So F all with P and P is P and P. So by law of identity, justified by law of identity. By law of identity. So it's by law of identity to take this F or bracket P and P with P and P. If and only if P and P and Q is equal to Q and P. Because this P and P is being substituted with P by law of independence, they are logical equivalent. P and P is equal to P. So substitute this P and P with P. Being justified by law of idempotent. So by law of idempotent, you substitute this P and P with P. Now I've now proved our assumption that P and Q is equal to Q and P. We then conclude. We say thus P and Q is equal to Q and P. We continue to this place. Now we are going to prove the converse. We are going to prove the converse so that by the principle of exceptionality, we then establish that law of commutativity exists. So let's prove the converse. Conversely, conversely, we say that Q and P is equal to P and Q. You will see that this Q and P, that is the right equivalent, has now become the first equivalent here. That means Q and the P. Now this P and Q that is left equivalent here is now P and Q, that is the second equivalent, the right equivalent here. So it is converse. We are going to prove it that it also exists. Then we then establish by the principle of stability that law of commutativity by quantitative statement exists. We then assume, we say, suppose Q and P is equal to P and Q. We assume the statement is true. The Q and P is equal to P and Q. We assume that it is true. That is, whenever the left equivalent is true, also the right equivalent is also true. Whenever the right equivalent is false, also the left equivalent is also false. We say the logical equivalent. So, and it is true. So we assume that it is truth. So we're going to prove it that it is truth. And it's our hypothesis. Say if this is true, also this also must also be true. Say if and only if Q and P, if and only if P and Q is tautology. Now you see that I have now transformed it to biconditional statement. That means Q and P equal to P and Q has now been transformed to biconditional statement. You have Q and P if and only if P and Q is tautology. Because whenever the left equivalent is true, also the right equivalent is also true. Whenever the right equivalent is false, also the left equivalent is also false. So if we validate this statement, there's no possibility getting falsity, always truth. We say that it is tautology, being justified by logical equivalent. Being justified by logical equivalent. If and only if Q and P implies P and Q is tautology. That means you have now transformed this biconditional statement to conditional statement and it still preserve tautology. So they are still equivalent, is still truth. So you see that whenever the antecedent is true, also the consequent is also true. So it means that this Q and P is a proper implication of P and Q. So if you validate this statement, there's no possibility of falsity, always truth. We say that it is tautology, being justified by logical implication. Being justified by logical implication. So this is true. Also, this also must also be true. Say if and only if Q and P is logical implication of P and Q. So, by the principle of logical implication, that means I say that if I say that Q and P implies P and Q is tautology, if and only if Q and P is logical implication of P and Q. So by principle of logical implication, we infer that Q and P is logical implication of P and Q, because this Q and P is a proper implication of P and Q, that means the consequent. So we say that it is true that P and Q exist. So this is true, also this also must also be true. Say if and only if Q and P is equal to Q and P. That means the logical implication is equal to itself. The logical implication is equal to itself. Because whenever the left hand side of logical implication is true, also the right hand side of logical implication is also true. In the same way, whenever the left hand side of logical implication is false, also whenever the right hand side of logical implication is false, also the left hand side of logical implication is also false. You say it is logical equivalent. So it is true that Q and P is equal to Q and P, being justified by identity, the sameness. Being justified by identity. That means the sameness. We continue to this side. So if and only if Q and P is equal to Q and P and bracket not Q or Q. You see that this, we have added Q, not Q or Q, to the right hand side of the equivalent, and is still logical equivalent to the left hand side of the equation. So it's still equivalent. So being justified by law of identity. Being justified by law of identity. By law of identity. So it's by law of identity that we state this Q and P with Q and P and bracket Q, not Q or Q. So if and only if Q and P is equal to P upon not Q and bracket not Q or Q. You have seen that it has not been specified. We transform this Q and P I mean this conjunctive statement to conditional statement by Christ Almighty God's grace. So and it's not intensified because it's not Q or P. That means not Q implies P. And not Q and Q is equal to T. And T and with any time set by that term. So it's equivalent to P upon not Q. That means not Q implies P. Which is now intensification of the left hand side of the equation. It's greater than the left hand side of the equation. He said that is intensification of the left hand side of the equation. So he said is intensification of Q and the P being justified by Christ the Almighty God's grace. Say if and only if let's try the other ink. If and only if Q and P is equal to P and bracket not Q upon not Q or Q upon not Q. You see that we have now distributed this not Q to the second conjunct. That's why I have Q, not Q upon not Q, or Q upon not Q. And it's equivalent to P. Because this Q, not Q upon not Q, is topology. Topology of anytime is same as topology. Topology and anytime is same as that term. So it's equivalent to P. And it's still integration of Q and the P. We say that is intensification of Q and the P. So being justified by distribution of implication. It's two distribution of implication that is take this implication not Q to the second conjunct of the statement. So being justified by distribution of distribution of implication. Being justified by distribution of implication. If I go to this side, say if and only if Q and P is equal to. We are going to revise this statement not Q upon not Q, that means the conditional statement to conditional statement. Because this statement, this not Q, is related from the conditional statement Q and the P. So whenever I want to revise it, it's going to be also in conjunctive statement. That means we have P and bracket not Q and Q or bracket Q and Q. So is being revised by Christ Almighty God's grace. It's through Christ Almighty God's grace that we revise these two conditional statements. So it's being justified by Christ Almighty God's grace. Being justified by Christ the Almighty God's grace. So if and only if, now you see that, and you see that this Q and P is equivalent to F. F of N times that is equivalent to Q and Q. And Q and Q is equal to Q. So, and Q, and it means that Q, you have P and D, Q, which is equivalent to the left hand of the equation. So, it's not logical equivalent. No more interpretation of the left hand of the equation. So, if and only if Q and P is equal to P, and this is equivalent to F. So F or with Q and Q. So this F is being substituted. This not Q and Q is being substituted with F by law of complement. So my law of complement is equivalent to F. That was it's being substituted with F. So being justified by law of complement. Say if and only if Q and P is equal to P and bracket Q and Q. You see that this F or bracket Q and Q is substituted with Q and Q, because whenever F is always at that time. So be justified by law of identity. By law of identity. Be justified by law of identity. So it's law of identity that substitute this F or bracket Q and Q with Q and Q. So if and only if Q and P is equal to P and Q. Now you see that this Q and Q is substituted with Q by law of idempotent. They are vertical equivalent. So we justify by law of idempotent. So if and only if, now I have now proved the converse, that Q and P is equal to P and Q. We then conclude, we say thus. We then conclude, we say thus. Thus, Q and P is equal to P and Q. So we have now proved the converse. Since I have now proved the converse, by the principle of externality, we then establish that P and Q is equal to Q and P is law of commutativity by conjunctive statement. Therefore, P and Q is equal to Q, and the P. We have now proved that law of commutativity exists. That means P and Q is equal to Q and P is law of commutativity by conjunctive statement. So at this juncture, we shall draw our curtain. Thank you, viewers.